student. Today we are going to discuss on liquid metal corrosion. If we want to remind what we have studied so far, actually in chemical type we have seen there are three different categories. Number one was oxidation due to oxygen only. Number two, oxidation due to other gases, and number three is liquid metal corrosion. As far as oxidation due to other gases, we have seen in the last lecture, it is mainly because of the gases available in the environment. They are carbon dioxide, sulfur dioxide, hydrogen sulfide, halogen, and in halogen, chlorine and fluorine are mainly involved. In that case, in fact, there are three different types of layer may be formed on the metallic surface whenever a metallic structure is exposed in any environment having this kind of various gases. So three different types of actually layer can be formed. Number one was actually stable, that was in the case of silver, and second one was it may be volatile type if the metallic structure is made of tin, and in petroleum industry, which was very much dangerous in nature, the attack due to hydrogen sulfide on mild steel. Although it is very corrosion resistant because of some inclusion of some organic component, it is very good. It is having very good mechanical properties and low cost. But unfortunately, because of some reason, this hydrogen sulfide undergoes ionization and ultimately mild steel is attacked by two different pathways we have seen in the last lecture. And today we will be talking on liquid metal corrosion. And to start with, let me tell you, basically all of us know that only metal which is liquid in nature is mercury. Here liquid metal consists of an alloy with low melting point that form a eutectic. Try to understand, eutectic is a homogeneous mixture of different substances that will either solidify or melt at a actually single temperature that will be lower than the melting point of any of the constituent. That is known as eutectic. If anybody asks you what do you mean by eutectic, then you have to tell that eutectic system is a homogeneous mixture of different substances which will either solidify or melt at a single temperature that is below the melting point of any of the constituent, and that actually melt that is at room temperature it will be in liquid form. Actually, practical example of this kind is, actually we know that it is your mercury, but gallium based alloy are being used because all of us know that gallium based alloy are having low vapor pressure and low toxicity also, and such metal and alloys are those which melts below 400 to 500 degrees centigrade. Now, as we know that this kind of corrosion actually takes place when a liquid metal, try to understand that, a liquid metal comes in contact with a solid metal at high temperature. I repeat, this kind of corrosion will take place only when a liquid metal comes in contact with a solid metal at high temperature, and therefore this kind is very much but often found in devices used in nuclear power. You understand that? And the main reason is due to primarily a physical form of attack on the metal surface, because of which it may proceed following two different pathways. Let me show you one by one. Number one is dissolution of solid metal by liquid metal and or internal penetration of liquid metal into solid metal. Try to understand. Actually, when a liquid metal will come in contact with the solid metal, there will be a physical attack, and what will happen? Either there will be dissolution of solid metal by liquid metal or internal penetration of liquid metal into the solid metal. To make it easy, let me give you some example to make you understand. Although it is not exactly the same, but to give you some kind of idea, I am telling you. For the sake of discussion, let us take a metallic structure. Say it is made of iron. Well, all of us know that iron is solid, and therefore it is S like this. S stands for solid. Suppose there is a liquid metal. This is your liquid. Let us represent it as L. Now, if it flow over the surface of the solid structure made of iron, what may happen? Before we say something about this, let me explain another thing. See here. Suppose it is a very relevant example. To make you understand, I am giving this example. Suppose it is iron. Little bit of water is fallen on it, and immediately this water is removed. Anything happens? Initially answer will be no. Now suppose some amount of HCl is there. Now it is also removed. What? Anything happened? The answer will be yeah. What? Actually, hydrochloric acid will react with iron, and some iron molecule will get diluted in hydrochloric acid, as a result of which this thing will be like this. What does it mean? If the liquid metal is reactive in nature, it will dissolve some metallic atom and get dissolved in it. And that is why, number one, dissolution of solid metal by liquid metal. It means when the metal is liquid, it is passing through another solid metal. There is a possibility that some atom of solid structure will get dissolved in it, and as a result, here this will be made of LS. Some S atom will get dissolved, will go into away. This is one possibility. Another possibility I am talking about. Try to understand that. Suppose this is an iron structure. Some amount of water is there. It is now removed. Initially, I have told, and you have also told, there will be nothing as such happened. But in fact, for the sake of discussion, let us assume that there are some cracks. In that situation, what will happen? There is a big possibility water will get inside through these cracks. And that is why we have written here internal penetration of liquid metal into the solid metal. What does it mean? If a liquid is in contact with the solid metal, there are two possibilities. Either there will be dissolution of solid metal by liquid metal and oblique out. Both are possible. If there is cracks, if there are some kind of cracks, there is a big possibility some amount of liquid will go inside, as a result of which L will get inside. Initially, I have told you it was pure, made of L. Now, if some S atom get dissoluted, then there will be LS. Similarly, initially this metallic structure was made of S. Now, number of liquid atom also get inside, and as a result of which now impurities will be there in the form of L. Here it is form of S. as a result. If these two things happen, what we can say? Because of this, we can say there will be number one, resulting intermolecular compound formation, and number two is mass transfer. Try to understand. I repeat, we have seen two mechanisms. We have seen two different steps which may be there. If liquid metal is passing through the solid metal, there are two possibilities. Number one, some amount of solid may get involved in it, dissolved in it, or if there is some cracks, liquid molecule may get inside. As a result, there are two possibilities. Intermolecular compound formation is possible, and number two, mass transfer is also possible. Try to understand that. Mass transfer, what do you mean by that? When it is going like that, some solid mass is with the liquid metal, and similarly, if this thing happens, some liquid mass is there with your solid system. And that is why, if mass transfer is there, mass transfer is troublesome, because it is always takes place in case of liquid system. But your intermolecular compound formation is very, very dangerous, because this will deposit in and actually under the surface of the structural material, as a result of which your entire metallic structure will get damaged. Now, in both the situation, you see, if this thing happened, initially it was pure liquid, now in it solid is also there. And if this thing happened, initially it was made of S, now L is also there. In both the cases, purity of both the metals, as in the case of liquid, as in the case of solid, will go off. Corrosion of this type is known as liquid metal corrosion, and this is predominantly found in many devices used in nuclear power. This is all about your liquid metal corrosion. You have to understand two important points. Basically, we know that as a standard substance, mercury is the only liquid metal, but we are talking about gallium. You know that while melting point of gallium is around 30 degrees only, because of its special characteristic property. And that is the most important part, which is being used in nuclear power station by nuclear devices, as a result of which this kind of corrosion is predominantly found in nuclear power. I am sure you might